Welcome to The Explainer. I am so thrilled you're here with us today because we are diving headfirst into a story of absolute sheer genius. We're going to explore how one man, a brilliant Serbian-American engineer named Nikola Tesla, literally wired the modern world. Specifically, we're going to zero in on an invention that completely shaped the entire modern electrical power industry from the ground up, the induction motor.
So how exactly did one man's mind wire the entire planet? Well, to get there, we kind of have to plunge right back into the dark, soot-filled world of the early 1880s. Before Tesla changed everything, our world was illuminated by gas lamps, steam power, and candles. Electricity was this brand new, wild frontier, and the infrastructure to power entire cities, it simply didn't exist yet. So how do we get from that dark era to the bright, electrified world we live in right now? To understand that, we have to look at the massive hurdles standing in the way of progress.
Section 1. The DC problem. Direct current. In the early 1880s, the status quo was entirely dominated by Thomas Edison. In fact, when Tesla arrived in the US in 1884, he actually went straight to work for Edison at the Edison Machine Works in New York. Now look, Edison's work in setting up a large-scale electric power utility with his direct current system was absolutely groundbreaking. There's no denying that. But it had some pretty severe limitations. You see, Edison's direct current, or DC, was a low-voltage system, and because it was low voltage, it could only travel incredibly short distances, usually just a mile or so from the power plant, before the power just totally dropped off. Plus, if a city needed high-voltage street lighting, like those popular arc lamps of the time, Edison's low-voltage system was completely incompatible. It was a massive, massive bottleneck for human progress.
Section 2. The AC solution. Alternating current. While working independently after leaving Edison's company, Tesla focused his brilliantly unique mind on alternating current, or AC. Unlike Edison's highly limited DC system, alternating current could be stepped up to incredibly high voltages for transmission over very long distances, and then stepped back down to safe, low voltages for use in homes and factories. It was totally scalable. It could power an entire nation, not just a few city blocks. But there was one massive glaring problem. AC power was fantastic for transmission, but there was no practical motor that could actually use it to drive the heavy machines of industry.
Section 3. The induction motor. Tesla's invention.
Tesla had this unbelievable theoretical breakthrough that he claimed to have conceived as early as 1882. He realized that if you used a polyphase alternating current, which is basically sending multiple alternating currents out of phase with one another, you could generate a rotating magnetic field. Think of it like an invisible spinning magnetic whirlpool. That was the key. It was the exact theoretical foundation needed to finally make an AC motor possible.
The practical magic of the induction motor, which he patented in May 1888, happens in 3 really elegant steps. First, that polyphase current creates the rotating magnetic field. Second, this field induces a current in the central rotor. And third, the motor spins entirely on its own. Older DC motors required a commutator with mechanical brushes that constantly sparked, they wore out, and they needed high maintenance. Tesla's AC induction motor was this simple, self-starting design without any of those sparking brushes. It was elegant, it was highly efficient, and it was practically maintenance-free.
And you don't just have to take my word for it. None other than Mark Twain, who was actually a close personal friend of Tesla, called this the most valuable patent since the telephone. Twain spent a lot of time hanging out in Tesla's laboratory, and he perfectly validated the absolute genius and magnitude of this invention. The induction motor was the missing puzzle piece that finally made the AC power system commercially viable.
Let's look at the actual financial stakes here, because they are wild. This shows just how desperately the industry needed this technology. In July 1888, the legendary industrialist George Westinghouse licensed Tesla's polyphase induction motor and transformer designs. Westinghouse paid $60,000 in cash and stock, which was a massive fortune at the time, plus a royalty on the horsepower produced, and he hired Tesla as a consultant for a whopping $2,000 a month fee. Westinghouse knew that with Tesla's motor, he finally had the complete system he needed to defeat Edison once and for all.
Section 4. War of the Currents. Extreme competition. This whole era was a true David versus Goliath arc. You had Tesla's superior AC technology, backed by Westinghouse, facing off against Edison's massive, entrenched DC monopoly. And the competition was fierce. Edison actually launched a brutal propaganda campaign, trying to convince the general public that alternating current was incredibly dangerous. On top of that, an 1890 financial panic nearly bankrupted Westinghouse Electric,
It got so bad it forced Tesla to eventually tear up his lucrative royalty contract just to save the company and ensure his AC system would survive. The stakes literally could not have been higher.
Section 5. The World's Fair, Columbian Exposition.
The ultimate public test for Tesla's technology arrived at the 1893 World's Columbian Exposition in Chicago. Westinghouse Electric won the bid to light the entire exposition with alternating current, and they proudly branded it the Tesla polyphase system. This was it, the ultimate proving ground. The whole world was watching to see if AC power could actually safely deliver on its massive promises.
Well, it was an absolute triumph. Westinghouse and Tesla demonstrated the incredible safety, reliability, and efficiency of their polyphase AC system directly to the American public. They even used rotary converters to supply power to the older DC exhibits. Tesla himself attended the fair, and he completely dazzled crowds by demonstrating his rotating magnetic field using the egg of Columbus, making a copper egg spin and stand right on its end using his two-phase induction coils. In one fell swoop, the World's Fair shattered public doubts and proved that AC was undeniably the future of electricity.
Section 6. Powering the World, Modern Electricity. Now let's look at how this builds to an even grander scale. In 1893, Edward Dean Adams, head of the Niagara Falls Cataract Construction Company, asked Tesla for advice on how to transmit the immense power generated at the falls. Naturally, Tesla advised that a two-phase AC system would be the most reliable way to do it. Based on Tesla's expert advice and that stunning demonstration at the Columbian Exposition, Westinghouse was awarded the contract to build a massive two-phase AC generating system right at Niagara Falls. They were literally harnessing the raw power of nature to electrify the industrial age.
The speed of this progress is literally breathtaking. Think about it. In just 8 short years, from the invention of the induction motor in 1887 to the Westinghouse deal in 1888, the triumph at the Chicago World's Fair in 1893, and finally the realization of the massive Niagara Falls system in 1895, Tesla achieved a rapid succession of victories. This explosive period of innovation decisively won the War of the Currents. Edison's DC standard was defeated, and Tesla's AC system officially became the foundation for global electrification.
So the next time you plug your phone into a wall outlet or switch on a light or just look up at a power line, I want you to ask yourself, would the modern world run without Tesla's rotating magnetic field? The electricity coursing through the walls of your home right now is a direct result of Nikola Tesla's induction motor and his unyielding belief in alternating current. His mind truly did wire the world. Thank you so much for joining me on this explainer, and keep exploring the incredible ideas that shaped